Hello, my name is John Broadwell. I'm the creator of the open source Serial Wombat project and also an independent embedded systems consultant at Broadwell Consulting Inc. In this video, we're going to take a look at some recent updates to the Arduino library that supports the Serial Wombat chips and their firmware, and take a look at what the changes are and give you an idea of what new features there are and a bug fix that shouldn't impact you, but if it does, let me know. Before we do that, I'd like to give a quick shout out to Steve in British Columbia, who sent me some neat information about his project. Steve is controlling a pool with his Serial Wombats, along with a DF Robot Wido, which is a board I hadn't used before, hadn't heard of that, but is controlling his pool and is using 4 Serial Wombats to expand the I/O capability of his DF Robot, driving some LEDs. He's also using a pH sensor, and perhaps most interestingly, he's using the pulse measurement to measure the flow control of what's going through his pool pipes. So really neat application. I'm really excited to see people using this out in the world for real world applications. So if you've done something neat with your Serial Wombat and you'd like to see it featured in one of the videos, by all means, hit me up at help@serialwombat.com. Send me a quick write-up and a few pictures, and we'll get it into one of the future videos. So great job, Steve. Now let's take a look at the changes that we've made recently. Since the end of May, I've made a few changes. In May, I saw a little bit of misbehavior on the I2C bus during a project I was doing using the Serial Wombat. It had to do with clock stretching. And for those of you who aren't familiar with clock stretching, essentially it's a way for a device that's on the I2C bus to tell the commander, hey, slow down for a minute. I'm not ready to receive bytes, or I'm not ready to send you bytes, so just be cool. And the way that it does that is by holding the clock line low on the Serial Wombat side. So you can see how this is how things normally work. We send out 8 bytes worth of commands. There's a slight pause, and then we send out the address to the Serial Wombat saying, hey, now I want to read back some of that data. At which point the Serial Wombat says, well, geez, dude, you only gave me 100 microseconds to calculate a command. I might be dealing with a pin update right now. Maybe I'm dealing with the rotary encoder, or, the PWM, or, whatever. But whatever it is, I don't have a response ready right a minute. I'm a microcontroller. I run firmware. I have to run interrupts. I'm not like the EEPROMs you're used to dealing with that instantly just change an address line and have the result available. So, Mr. Arduino, please be patient, and until I'm ready, I'm going to hold this clock line low. You can see it does that. In this case, for this particular packet, it took the Wombat chip about 300 microseconds to finish doing whatever it was doing and formulate a response, at which point it sent the next 8 bytes. So that's the way things are supposed to work. One of the optimizations that I put in the Serial Wombat firmware was for some commands where you don't care about the response, it would send the command and not ask, then send another command immediately following that. And under those circumstances, it's supposed to do the clock stretch on the next command so that we have time to finish processing the prior command before we process the next one. I saw a set of circumstances that I've not been able to reproduce where that particular functionality wasn't working. It worked great in the command response version, but in the case where we sent multiple commands, one after another, it wasn't consistently doing the clock stretching, which meant that some of those commands were corrupting the command that had preceded it before it could be fully processed. So that's not awesome. So I'm still trying to hunt that down and reproduce it. It happened to me once in May. I don't think it's a pervasive bug for a lot of people. Haven't had any complaints from the field, and I've only seen it once in months and months of testing, but it's not right. So as a workaround for right now in the Arduino library, in the case where we are only transmitting as opposed to transmitting and receiving, normally there's separate logic for that. For the time being, I've short-circuited the send-only code and passed it off to the send receive code, and we just throw away the result. So the net result of that is that even if we only want to send a command, we're going to send the command and ask for the response, because as near as I can tell, the command response aspect is working just great. So again, I won't know that for 100% until I can finally reproduce it and fix the bug. But for right now, I think this makes the library more reliable. Again, haven't had any complaints from the field. Only saw it once myself in 5 months of development, but don't know what the deal is, and so tried to put a fix in place for that. Next is the check-in of some code that adds some minor improvements. The ability to read and write directly the memory on the microcontroller, as well as read out flash memory. That's probably something that none of the end users are probably going to want to do, but it's very useful for me. It's implemented in the firmware protocol, and so I wanted to have that capability. I'm currently using that to try to debug the clock stretching issue by continuously writing to a variable and then only occasionally reading it back and see if the last write that I wrote was effective or not, and then doing some variations on that. Again, I haven't been able to trigger that bug. It's, for good or for bad, it's been 100% reliable for days at a time. So still trying to do that. I had another user, Snap Forward, on our YouTube channel who said, hey, we're having a little bit of trouble reading AC voltages. Is there any way I can read minimum and maximum values on the A to D conversions? And it turns out there is. It was implemented in the firmware, but I never pulled the interfaces up to the Arduino library for some reason. So that is now available. So on any of our analog channels, you can get the min and max values since the last time you asked. They're sampled at 1,000 hertz, so that's fairly decent. And those are available. There's documentation available for those on the GitHub IO pages page. The read maximum millivolts, read maximum counts, read minimum millivolts, read minimum counts. So that potentially lets you get the amplitude of an AC signal as long as it's sufficiently slow that 1,000 hertz sampling would get your peak and your crest to a reasonable degree. So that's in there. Fixed a variety of compiler warnings. It turns out on some platforms, things that are compiler warnings turn into errors on other platforms. Having some issues with some platforms where we do a cast of an embedded type, an enumerated type to a uint 8 or 32 without explicitly casting it. It didn't like that. So that and a few other compiler warnings. Added unique ID. So each of the microchip PIC 16F 1520 214s that the Serial Wombat firmware runs on has access to the unique ID in that chip. Microchip has a 9-byte value that's some arbitrary uniqueness that they create. It would have been neat if it was a MAC address format, but it's not. But anyway, that unique ID is available to you if that's something that you're interested in. And finally, the I2C to UART. I had kind of done a hand wave on the timeout values, and so now there's a proper millisecond-based timeout between bytes. You'll typically want to set that a little bit longer than what you might set it for a onboard UART, because there's extra latency of making the hop to the Serial Wombat chip then going out on the UART bus. So that's version 1.06. Then it turns out that in sometime after I was working on 106, I started doing some more debugging, trying to find that clock stretching bug. I removed the fix, forgot that I removed it, checked in the code, and then had to roll that back out. So that's the 107. 107 isn't very interesting. And then 108 adds a unique ID example that shows how to use the unique ID feature. So let's take a look at that real quick right now. Under Arduino, go to File, Examples, and if you've downloaded the latest library, under Serial Wombat, there's a unique ID. This is what that looks like. Basically, we just instantiate a Serial Wombat chip we start up our serial so that we can dump stuff out. We start up the I2C bus, and then we do a begin on our Serial Wombat chip. And then you'll want to read the version first. That actually, you have to have at least one read of things that kicks off a read of these other items, and they get cached. So we'll do a read version, at which point then the initialization routine for the Serial Wombat firmware has run, and we've pulled up some of these values along with the version number and some other things. The unique identifier length for the PIC 16F 15214 identifier length is going to be 9. For other platforms, say ones that had built-in Wi-Fi with a MAC address, it might be a different length. But this is how you get it. Basically, you get the identifier length, then you just pull out that number of bytes. Microchip also implements a device ID for each of their chips. You can pull that up. It should always be the same value unless there's some offshoot in the future that's backwards compatible. And the device revision isn't useful right now, but it could be potentially in the future. Each time they revise the mask that creates the microcontroller gates, then they update the device revision. So if it turns out that they either fix or introduce errors, that we could do a workaround for at the Arduino level by reading that device revision. We could find out what revision of silicon we're on. Again, not useful now, but feels like something that might pay off in the future. So let's run this real quick. And we'll take a look at the serial monitor. And there it is. Every 2 seconds it's querying it. Yep, we got a Serial Wombat 4B, firmware version 203. The unique ID length is 9. This is what the unique ID is for the chip. I've run it against different chips. It really does change. The device ID and device revision are in there, and those have been consistent for all of the chips that I've seen. So that's about it for today. As always, please subscribe if you want to see updates that are going on with the Serial Wombat project. Likes are always appreciated as well. If you have any questions, leave them in the comments below. And, let me know what's going on. Are you using any of these features? How are they working for you? If you have suggestions, as we said, one of our users said, hey, I really need to measure the min and max, and boom, it turned into a feature. So, I really try to be responsive. I've tried real hard to build a project that is what I think will solve problems for you guys, but, I don't know everything. So, let me know what you need, and I'll see what I can do. Also, we'll have a new version of the Serial Wombat coming out in the future on the PIC 24FJ 256GA702, which will have a lot more capability. I got a lot more flash space to work in that. So there'll be, really room for a lot of new interesting ideas. So, let me know what you're up to, and keep in touch. The Serial Wombat firmware is available on GitHub and is constantly being updated. Subscribe below so that you can see the latest features and videos that come out as we fix bugs and add new features to the Serial Wombat. The Serial Wombat open source project was created by Broadwell Consulting Inc. Broadwell Consulting Inc. provides help developing medical devices with a focus on developing embedded firmware, which is compliant with IEC 62304, ISO 14971, and ISO 13485. as well as remediation assistance for products already in production. For more information, contact John at Broadwell Consulting. Support requests for Serial Wombat should be sent to help@serialwombat.com and will be answered on an as-available basis. Questions sent to John at Broadwell Consulting about the Serial Wombat will not be returned.